Okay, so welcome to part 2 of graphing trig transformations. All right, yesterday you talked about amplitude and you talked about vertical shift or midline and how changing the equation changes where the graph is. Okay, the normal graph, we did 2 days worth of what the normal function looks like. And then yesterday I was talking about how we could make it taller or shorter. We could even flip it upside down and we could do the midline. Right, we could raise or lower it up basically by doing a vertical transformation or a vertical shift, and it basically moves where the middle of the graph is, right? Okay, so now we're going to work with B. Okay, so we've already done A and we've already done D. That was what we focused on yesterday. So today we're going to focus on B. All right, and B is the variable that changes how long it takes for your graph to complete one full cycle. Okay, so think about a normal sine and cosine function, what we graphed on Thursday and Friday. Okay, a normal sine and cosine function, when we graphed it, right, the cosine looked like, or the sine looked like this, and the cosine looked like this. Okay, you had to go one full trip around the unit circle, right? That's 2 pi. So when we did our graphs, we did 0, pi over 2, pi, 3 pi over 2, back to 2 pi. Okay, full all the way around the circle to make one full curve. Okay, and when I say it makes one full curve, what I'm talking about is if you were to keep drawing your sine function, okay, that's one full curve, right? And then it would basically repeat itself at a different location or a different start, and it would just keep going forever and ever. Okay, it's a function. They just keep going as long as, you put the arrows on the end. Cosine is the same way. Okay, one full curve for cosine, right, looks like this. Starts at 0, starts at 1 rather, goes down to -1 and back up to +1. Well, if you kept graphing it, it would keep going forever and ever and ever. Okay, we care about how long it takes for it to go through one full cycle. And today we're going to change that. We're going to make it cycle faster, or we're going to make it cycle slower. Okay? So if we change B, the amount of time that it takes to go through one full cycle, or one full curve, will change. Okay? And we have a very specific formula that you need to be writing down that we use to figure out, what our new period or new cycle is. Okay? And it's not bad. It's based on what we know, that a regular one takes 2 pi. So the formula is we take 2 pi, right, what it would take for a normal function, and we divide it by whatever B is. Okay? And that gives you what we call the period or the cycle of the graph, how long for it to go through one full curve. Okay? Very, very easy. You're just picking out the one variable. You don't have to worry about changing signs. You don't have to worry about doing anything like that. No positive or negative. It's just whatever number is in front of the x, right, inside the parentheses, will be divided into 2 pi. And we'll see what our new cycle is going to be. Okay? All right, so let's try. We're going to work our way from easy to hard. Harder. All right, so 2 pi divided by b. All right, so let's take a look. First one, okay? I'm not putting any extra pieces on there. No amplitudes and no vertical shifts yet. We're going to get to that where you put it all together. Okay? So y equals sine of 2x, okay? So a hasn't been changed. The d out here isn't. This is specifically b. It's what's in front of x. All right, so we take 2 pi, which is our normal period, normal cycle, divide it by 2, okay, and then simplify. You get basically 1 pi, right? So that all that means is that when you make the little X marks on your graph, your ending point is not going to be 2 pi, it's now going to be 1 pi. But here's the only difference, because we're not really going to make the graph look any different at all, okay? It's still starting at 0, and we still have 5 points, right? Starting point, the 3 middle points, and the end point. Well, since I start at 0, and my graph makes one full curve in 1 pi, that's my ending point. It's 1 pi. Okay, and we're going to do the same thing that we did before. What's halfway between 0 and 1 pi? Pi over 2, right? Or 1/2 of pi. Okay. What's halfway between 0 and pi over 2? What's half of half? Good. Pi over 4. All right, what's halfway between pi over 2 and 1 pi? Well, what's between half and 1? 3/4. So 3 pi over 4. Now here's the thing. It's the same pattern. It's still going to start at 0 and go up to 1 and back to 0 and down to -1 and back up to 0. The pattern of the graph has not changed. All we've done is change where it happens. Okay, so don't freak out thinking it's, oh God, now I have to go look on the unit circle and I have to figure out what sine of pi over 4 is. Nope. Think about it. Here's our unit circle, right? And imagine you have all those, things on there as far as your points. 0, 0, 1, -1, 0, 0, -1. Okay, so you'd have to go all the way around to hit those, right? To actually get to those whole number points that we use. So if I make my graph cycle faster, imagine basically what it does, go back to my arrow, is it does this. That's up here, and that's here. It makes it cycle faster. It changes basically those coordinates. Now you don't have to, rewrite the unit circle. You don't have to change all the coordinates. You just need to know that we're still going to be using, the normal sine function, right? 0, 1, 0, -1, back to 0. We're still going to be doing that even when we change the period or the cycle. We're just going to change these marks down here as far as what they correspond to. Okay? But the pattern is still the same. Now, I know you're thinking, well, what if I change the amplitude or if I move it up and down? The pattern still didn't change. Even when we reflected it, it just flipped it over. But the pattern has always been start, well, unless you reflect it, go up, come back to the middle, go down, go back to the middle. That doesn't change. It just changes where it happens. And that we do by just changing the X marks right here. Looks just the same as the graphs we did yesterday. Even technically looks the same as a normal sine graph. You'd have to look at the X values, right, on your X coordinate or your X axis to see that the graph has changed because it's finishing at 1 pi instead of 2 pi. It means it got faster. Okay, so same thing as yesterday. Let's go through this. What is my amplitude? 1. What is my midline? Please make sure you're writing this as a function. Y equals 0. What else? Oh, well, we have something we can add now. We can put period or cycle, and my period or cycle is 1 pi, and my range. My range is still from -1 to 1. I haven't changed that. Okay, so we're adding one more piece of information. How long does it take for the graph to go through a full cycle? All right, and I've got several examples to go through. You should be copying these down, making sure these are in your notes so that you have them to use. I don't do these for me, guys. These are literally for you so that you can use them as examples when you're doing your classwork. All right, so this one, y equals, and that's example 2, y equals cosine of 1/2 x. Okay, so in this case, b is equal to a half, right? So if I do 2 pi divided by a half, well, we don't technically divide by fractions, right? If you want to think about it in terms of doing this by hand, we don't divide by fractions. Instead, we multiply by the reciprocal. Well, the reciprocal of 1/2 is 2 over 1. So that's 4 pi. Okay? If I divide something, 2 whole pizzas into halves, I've got 4 halves. So that's why it gets bigger. All right, so again, same issue. 1, 2, 3, 4. 4 pi is now my ending. No big deal. Right? It's still going to go from 1 to -1, no big deal. It's still going to have the same pattern. The only thing that's going to change is my X markers. Okay, so what's halfway between 0 and 4 pi? Very good, 2 pi. What's halfway between 0 and 2 pi? 1 pi, no problem. What's halfway between 2 and 4 pi? 3 pi, no problem. Same pattern, I haven't changed amplitude or vertical shift or anything. So first one's at 1, and then 0, and then -1, back to 0, back to 1. So there's my cosine function. And the only thing really is it just took longer to get to the end. It took 4 pi instead of 2. Okay, so once again, write it out. Amplitude is still 1. There's nothing there in front of the cosine. Your midline is still y equals 0. Your period or your cycle is now 4 pi. That's how long it takes to complete one full, curve. All right, and then your range is still -1 to 1. We haven't changed anything else. Messy. -1 to 1. Okay, so now let's try adding another transformation in there, because eventually you have to be able to deal with all 4. Okay. Well, no, actually let's make this smaller then. Y equals sine of 4x, and in this case b equals 4. Okay, so 2 pi divided by 4, we simplify that. Your period is now pi over 2. Okay, so that means we start at 0 and we end at pi over 2, but all we're doing is finding half. Okay, that's all we ever do is find halves. So what is halfway between 0 and pi over 2? What's half of half? 1/4. Okay, well, it's going to get a little weird, but we can get it that way too. What's halfway between 0 and 1/4? What's half of a fourth? 1/8. Okay, no big deal. And here's going to be the little weird one. What's halfway between a fourth and a half? Okay. So if you have to, midpoint basically means you add them and divide by 2, right? In your calculator, you could add 1/4 and 1/2, get your answer, and then divide it by 2. Well, 1/4 plus 1/2 is 3/4. 3/4 divided by 2 is 3/8. So that's 3 pi over 8. Okay? But all you're doing literally is just taking half every single time. Half between the first and the last, and halfway for each of the middles. Sort of like doing quartiles back in probability and statistics. Okay, so again, the picture has not changed. This is a sine function, and it's going from 1 to -1. Notice the 4 is not out here, it's in here. It's not A, it's B. So the picture has not changed. We're still starting at 0, going up to 1, going back to 0, going to -1, going back to 0. Okay, so that has not changed. All we've messed with is how long it takes for the graph to finish. So our amplitude is 1. Our midline still y equals 0. Our range is still from -1 to 1. Okay, the period, how long it takes for the graph to bounce and go through a complete curve, is pi over 2. So we can make it smaller. And, your calculators, either the little skinny yellow ones or my graphing ones, will do the fractions. Okay, they have that capability. All right, so now let's get serious. Okay. So we're going to do this one piece at a time. We're going to deal with the period first, the B. Then we'll talk about the transformations, because here's the thing. That number right there doesn't do anything as far as transforming, making the graph go up, down, make it taller, make it shorter, make it go upside down. That has nothing to do with it. The only thing this controls is whatever these are, and that's it. Okay, so if you set up your graph first based on your period, Then you can go back and do like you did yesterday and deal with your transformations, right? And that's where you start dealing with, okay, so now, where is my graph going to start? Where does it go? Does it go upside down? Then you can deal with all of that. For right now, let's set up the period, and let's set up the x's. So our period is now 1 pi. So we've done that. That's from 0 to 1 pi, and we've already done this. So what's halfway between 0 and 1 pi? Half of pi. What's halfway between 0 and 1/2? Half of a half. It's a fourth. And what's halfway between a half and 1 is 3/4. So, right, so 3 pi over 4 is what we call it, or 3/4 pi. Okay, so now let's talk about what's actually happened to the graph. Okay, remember that these transformations all affect the y value, right? If you're stretching it, then you're making your y values that much bigger or smaller. If you're making it go up or down, then you're making your y values go up or down. Okay, so we would take all of our normal cosine points, right? Our normal cosine points would start at 1, right? 1, and then go to 0, and then -1, and then back up to 0, and then back up to 1, right? These would be our y values, our normal ones. And those don't change. Okay, so that's what we always start with. Well, we're now making them 3 times bigger. Okay, no problem. So now my y values are going to be 3, 0, -3, 0, +3. No big deal. Okay, so my first part, instead of starting at 0, 1, is now going to start at 0, 3. That's still going to be at 0. That's the second point. That's just what it does. The next one's going to be at -3, and then at 0, and then at +3. Okay, there's the graph. And this is really not that much different from what we did yesterday. We did the transformation yesterday. The only thing we're changing today is those little tick marks along your x-axis that show where those easy points that we deal with are. All right, so let's actually give everything up. What is the amplitude now? Should be 3. Midline should still be y = 0. We didn't move it up or down. Okay, so the period, or the cycle, is now 1 pi. And my range has definitely changed. It's now from -3 to 3. All right, so time to put one all together. Okay, so again, deal with the period cycle change first, right? Determine what that is and set up your tick marks, and then we'll talk about what the y values are going to happen. Now remember, this is a sine, so what would your normal y values be? 0, 1, 0, -1, back to 0. And you can write that every single time and then just apply your transformations, because that's just going to tell you where your y values are going to be every time. Okay, so my new period is pi over 2. Okay, so 0, 2, 3, 4. It's now pi over 2. And we're just going to keep taking a half. And if you have to put this in your calculators, 1/2, that's fine. Just remember to put pi on your answers. What's half of a half? A fourth. What's half of a fourth? An eighth. And again, we did this one already. What's halfway between 1/4 and 1/2? 3/8. All right, and if you had to put this all into a common denominator, that would be 1/8. 1/4 is 2/8, 3/8, and a half would be 4/8. Okay, these do actually, split into even pieces. All right, so let's talk about the transformations that have happened. Okay, and again, like I said yesterday, you have to do these in order. So I'm going to take my y values and I'm going to multiply them by -1. So times -1, and then I'm going to add 3. Okay, well, 0 times -1 is still 0 plus 3. 1 times -1 is -1 plus 3 is 2, and it's a positive. 0 times -1 is 0 plus 3. Okay. -1 times -1 is 1. Remember, double negative. Plus 3 is 4. And 0 times -1 is still 0. Plus 3 is a positive 3. Okay, so I flipped the graph over, right? So it's going down first now instead of up. And then I just move the whole graph up 3. So all I need now are just my y values at each of my tick marks. Okay, 2, 3, 4. No problem. My first tick mark 0 is at 3. My second one is at 2. Back up to 3. Up to 4. Back down to 3. There we go. Okay, no problem. So you have 5 problems to do tonight. The graphs are already on the page in Canvas. It's called Transformations 2. I'm going to be live teaching tomorrow. Okay, today I'm spending most of the day in the hospital, so send up a good thought for me and my husband. So, but tomorrow and the rest of the week I will be live teaching, so we'll be able to go over all these questions. In fact, pretty much tomorrow is all we're going to be doing is more practice on this. And I might figure out a way, so everybody needs to bring their iPads charged tomorrow, please. I might find a way for you to be able to submit answers instantly, or we may even, I don't know, do a Kahoot where I can actually see what answers you're putting in. Or if not a Kahoot, I know Quizzes does it, and I think even Nearpod does it, where you can put in answers and you can submit them to me instantly. So we might be able to even do some practice like that tomorrow. All right, take it easy. Have a good day. I will talk to you tomorrow.